Okay, we're going to finish up the test 1 review sheet with questions 18, 19, and 20. And in this question, question 18, it says that we want to find the slant asymptote. So it's straight up telling us there is a slant asymptote. And I can prove it to you. Remember, a slant asymptote exists if the power of the numerator is 1 higher than the power of denominator. And it is. This is the second power in the numerator, first power in the denominator. So this function definitely has a slant asymptote. And we're going to find it. Also find the y-intercept and the two x-intercepts, okay? So we're going to do them separately. Let's go ahead and start with the slant asymptote. None of them really work together. Basically, to find the slant asymptote, you just need the numerator and the denominator to be in factor or in standard form, and they already are. So what we're going to do is we're just going to do synthetic division, and then we're going to ignore the remainder. Okay. So we have x minus 6. We're going to change the minus 6 to a plus 6. We're going to put that in a half box, 6 in a half box. Then we have 1, negative 5, and negative 24. 1, negative 5, and negative 24. I'm pretty sure this is the easiest synthetic division that we have done so far in any of these videos. Okay, we're going to bring down the 1. 1 times 6 is 6. 6 plus negative 5 is 1. 1 times 6 is 6, and 6 minus 24 is negative 18. Now, when doing the slant asymptote, the remainder is meaningless. We do not need the remainder at all. It doesn't matter what the remainder is, so just ignore it. This is what we need. We started with x to the second power, so we're going to go down to x to the first power. So this is 1x to the first power, 1x to the first power. Well, that's just x. We don't need the 1 in the first power. And then this is a positive 1, so x plus 1. So that's our slant asymptote. Our slant asymptote is y equals x plus 1. Okay, that is our slant asymptote. So we're done with the slant asymptote. Now let's identify the y-intercept. The y-intercept, all we have to do is take the constant at the end here, negative 24, and divide it by the constant of the denominator. Negative 24 divided by negative 6. So negative 24 divided by negative 6 is equal to positive 4. And therefore, the y-intercept is at 0, 4. Done. All right, moving on to the x-intercepts. To find the x-intercepts, all we need are the zeros of the numerator. So we completely ignore the denominator. We just want the numerator. So we're going to write x squared minus 5x minus 24. We're going to set it equal to 0. We're just going to find the zeros of this. Well, this is a quadratic, so we could use the quadratic formula, or we could factor it if it's factorable. Is it factorable? Are there two numbers that multiply to negative 24 and add up to negative 5? There sure are. They are negative 8 and positive 3. So negative 8 times 3 is equal to negative 24. Similarly, negative 8 plus 3 is equal to negative 5. And so we've got our two numbers, negative 8 and positive 3. So x minus 8 is one of them, and x positive 3, that's plus 3, is one of them, equals 0. Okay, so we have factored, and now all we have to do is set each one of these equal to 0 separately. So x minus 8 equals 0, x plus 3 equals 0, add 8, and we get x is equal to 8 minus 3, and we get x is equal to negative 3. Therefore, our x-intercepts are 8, 0, and the other one is negative 3, 0. These are our x-intercepts, and we have identified the slant asymptote, the y-intercept, and the x-intercepts. All right, in 19, we want to identify the vertical asymptotes and the horizontal asymptote of P of x. So this is saying that there may be more than one vertical asymptote, but there's only one horizontal asymptote on this one, and there usually is only one horizontal asymptote. And so let's find the vertical asymptotes first. The way you find the vertical asymptotes is you solve for the zeros of the denominator. Thankfully, this denominator is already in factored form, so all we have to do is set the denominator equal to 0. To set the denominator equal to 0, we set this equal to 0, so 4x plus 3 equals 0. And then we set the other one equal to 0, x plus 5. X plus 5 equals 0. So over here, we're going to subtract 3 from both sides, and we get 4x is equal to negative 3. Then we divide by 4, and we get our vertical asymptote, x is equal to negative 3 over 4. So this is one of our vertical asymptotes, okay? Our other vertical asymptote will come from this x plus 5. We're going to subtract 5, and we get x is equal to negative 5, and that is our other vertical asymptote. So we found our two vertical asymptotes. Now we want the horizontal asymptote. Now, here's the thing. We need to look at the power of the numerator and the power of the denominator. In order to do this, we have to turn the denominator, into standard form. We have to convert this into standard form. So we're going to have to do 4x times x, which is 4x squared, then 4x times 5, which is plus 20x, then 3 times x plus 3x, and then 3 times 15, or 3 times 5, I'm sorry, which is 15, plus 15. Okay, so the denominator, if we combine the 20x and the 3x, becomes 4x squared plus 23x plus 15. Okay, and what we're going to do now is compare the degree of the numerator, which is 2, to the degree of the denominator, which is 2. If the degree of the numerator is smaller than the degree of the denominator, then the horizontal asymptote would just be y equals 0. But that's not the case here. Here, the numerator degree is 2, the denominator degree is 2, and so what we do is we go to the lead coefficients and we do a fraction of the lead coefficients. We do 8 over 4. And so the horizontal asymptote is going to be 8 over 4, and 8 over 4 is 2. So the horizontal asymptote is y equals 2. And we are done with 19. All right, last one, number 20. It says find the coordinates of the whole of this rational function. So that's all we have to do is just find the whole. Now it's telling us that there is a whole. Now the way we find the coordinates of a whole is we find the zeros of the denominator, okay? And then we plug the zeros of the denominator into the numerator and find out if it makes it equal 0. So if a number makes the denominator equal 0 and it makes the numerator equal 0, that means that it's a whole, okay? So let's find the zeros of the denominator. We got to set x minus 2 equal to 0 and x plus 3 equal to 0, okay? So x minus 2 equals 0, x plus 3 equals 0, plus 2, and we get x is equal to 2. Minus 3, and we get x is equal to negative 3. So the zeros of the denominator are 2 and negative 3. So now what we're going to do is we're going to use synthetic division to plug 2 and negative 3 into the numerator, right? Just like, you know, the remainder theorem. So we're looking to see if the remainder is 0. So let's plug in 2 first, okay? And our numbers are 1, 2, negative 40, and positive 64. So 1, 2, negative 40, and 64, okay? And bring down the 1. 1 times 2 is 2. 2 plus 2 is 4. 4 times 2 is 8. 8 minus 40 is negative 32. Negative 32 times 2 is negative 64. Negative 64 plus 64 is 0, and there's our remainder, 0. So 2, if we plug 2 into the numerator, we get 0, and therefore there is a whole at 2. Now, just to make sure, let's make sure that there's not a whole at negative 3 also. So let's do synthetic division on negative 3. So we'll do 1 and 2 and negative 40 and 64. Bring down the 1 times negative 3 is negative 3 plus 2 is negative 1. Bring that down. Negative 1 times negative 3 is 3. Plus negative 40 is negative 37. And negative 37 times negative 3 is positive 111 plus 64 is 175. Remainder is not 0. And therefore, negative 3 is not a whole. That means that x equals negative 3. This is a vertical asymptote, and this one is a whole, okay? So now what we're going to do is, since this created a whole, we're going to take these 3 numbers down here. We're dividing x minus 2 out through synthetic division, and it leaves us with x squared plus 4x minus 32 in the numerator. So what we do is we're canceling out an x minus 2, or another way to look at it is that the numerator can be factored into x minus 2 times x squared plus 4x minus 32. And now we can cancel the x minus 2 because we have one in the numerator and the denominator. And we now have x squared plus 4x minus 32 divided by x plus 3. And now we can plug that 2 in. The 2, we can plug it back in here for x, and it won't give us 0 over 0. It'll give us a number, and that'll tell us the y value. So we know that the x coordinate is 2. Now we just have to find the y coordinate. So we're going to put a 2 in here, and in here, and in here. And so we'll have 2 squared plus 4 times 2 minus 32, all over 2 plus 3, okay? All right, so 2 squared, that's 4. 4 times 2 is 8 minus 32. 4 plus 8 is 12. And 12 minus 32 is negative 20. So we have negative 20 in the numerator. 2 plus 3 is 5. And so this is our answer, negative 20 over 5. And negative 20 divided by 5 is negative 4. So there is a whole at 2 and negative 4. And that's it for the test 3 review.